Duh. Paw washing obviously is even more important than it was before. You've got to wash those paws when you come in. Lecture questions. We'll have lecture questions on Monday. We'll have lecture questions on Tuesday. We'll have the quiz on Friday. Anyone shocked? No? Okay, because that's what we do every week. Now, that's for this week. I'm playing it by ear. I'm kind of hoping that we can go back to paper after this week. The guy who came up with the idea of a mole, okay? The mole is also known as Avogadro's number. Mr. Pilcher, what do I really need to write down for this slide? You need to write the mole equals Avogadro's number. That's what you need to write down for this slide.
Why did you get our packets out? This isn't in our packet.
No, this isn't in your packets, but you'll need your packet soon. I said packets, notebooks, and periodic tables, right? I said notes. Your notes. You're fine. You're fine. Cane sauce, Avogadro's number, yada yada yada. This man, fine.
Did he invent avocado?
No, he didn't. Avogadro. He's so proud of himself. So, for example, if I'm like, okay, Colin, or no, I mean Mr. Howard, be like, okay, that's just two ways of saying the same thing. We're talking about the same thing there. If I say the mole, I mean Avogadro's number, be like, okay, you just said the same thing twice. Those are the same thing. You understand what I'm saying? Okay, great. Now, you don't have to write this part down. I'm just letting you know the history. Is that this number originally came from the idea of how many atoms are in 12 grams of carbon. Okay? How many atoms are in 12 grams of carbon? This is why carbon's formula weight is 12. Okay? You do not need to know that. You just need to know the mole equals Avogadro's number. That's all you need to know so far. Now, I got pop quizzes here. These are really easy. Okay? Here, Lexi, you'll answer the first one. When I say the word dozen, what do you think? What number comes to mind when I say dozen? Great. Congratulations. You passed. Zach, when I say a pair, you think of the number what? You got it. Cece, when I talk about a decade, what number comes to mind? Okay. Now, John, this one's a little harder. When I say, he's like, why'd you pick me on this one? Ream, do you know what number that is?
500?
Yeah, it's 500. Actually, I revealed that. Okay. So when you see those words, they just mean a number. That's all those words mean, okay? This is a ream of paper, for example. This is 500 sheets of paper. That's where they come from.
That's why they call it a ream of paper.
That's why they call it a ream of paper. A ream means 500. That's it. Nope, they're not fancy. Ream means 500. Now, chemists use moles to count molecules in chemical reactions. Mr. P, what all do I really need to know? You need to know that moles count molecules. That's what you really need to know. The mole is used to count molecules. Hey, I'm a baker. I want to count all these donuts. You count them in dozens. Hey, I'm a chemist. I want to count all these molecules. You count them in moles. Okay? A mole is just a number that we use to count molecules. That's it. Kind of, sort of. That's it. That's all it is. Okay, so it's just a number.
Yeah, it's just like you cut the word in half
Yeah.
and then add the S on that.
Well, you cut the
You just take the
like
clue
you
out.
cut the clue out, but it's not like any clue.
Here's what 1 mole is. Okay? You absolutely have to write this down. Here's what 1 mole equals. 1 mole equals 6.02 times 10 to the 23rd.
Oh,
Obviously.
Oh,
Times 10 to the 23rd.
So simple.
Times 10 to the 23rd.
will we ever know that?
So here is what that number is. That would be 602 000 000 000 000 000 000 000 000.
I feel like that's a song. Have you ever thought about freestyle rapping?
Oh man.
young coach on the track.
Yo, what's up to DJ Pilch out here? Alright, anyways.
So trust you, he's gonna formulate you. Let's go.
He's gonna Just like tomorrow's lab, my album would be fire.
What have you been doing tomorrow? Album.
Yo, I'm a chemistry teacher. I'm here to teach. Alright, anyways. Population of the U.S. So this is a large number, yes? Here's the population of the U.S. as of 2 years ago when I first made this slide. It's about a little over 300 million. Do you see how that number is a lot smaller than this number?
Yes.
Yes.
Here's the population of the world. It was about 7.5 billion. You see how that number is smaller than that number? Okay. A mole is kind of a big number. How big is this? Oh, I don't know. Here's a question. You guys know what a poppy seed is? Like those tiny little seeds that go on muffins sometimes? Poppy seed muffins?
Poppy seeds. There was
They're
a
really
song
tiny.
about poppy seeds.
Poppy seeds. Here we go. Mr. Spade, if I had a mole of poppy seeds, you know, how big do you think that would be? Would it fill up my sink? This classroom? How big do you think that would be?
602,000 whatever. No, whatever.
602,000 whatever?
On a scale of
Do you think it would fill up my whole classroom? Like,
No, I think it'd be bigger.
you think it'd be bigger than my whole classroom?
Poppy
Not
seeds?
the whole school?
Have you ever seen a poppy seed? It's like,
Yes, I just said what it was. A mole of poppy seeds would
Fill the whole school.
fill
The whole school.
Lake Erie
Like, that's a pretty
Yeah,
big
pretty
thing.
400 times.
Oh.
A mole of poppy seeds would fill Lake Erie 400 times.
Does that feel like we're all doing this?
Absolutely not. Not a chance.
Well, you never truly.
A mole of popcorn kernels. Anyone want to guess what that would do?
about the
The
same.
whole Earth. Fill the
9
ocean.
Earths.
9? Good
The
gracious.
sun.
Dang.
Huh?
The sun.
The
Fill
sun?
ocean. Right, the sun will
Do
burn
do you know how big the sun is?
Doesn't matter. It's a mole.
A mole of popcorn kernels would cover the entire United States 9 miles deep.
Oh, wow.
Wow.
You can cover the entire United States up to 9 miles.
So we're
It
gonna
would
die.
cover all. It would cover all.
What that means is there's no way there's that many popcorn kernels in existence.
How do you know?
Uh, because that would like,
How do you know they're not making it?
if you spread them out across the whole world, then we'd all be like walking through popcorn kernels. You know what I mean?
I guarantee you we have enough.
What if-
kernels to cover
What if I stacked a mole of reams of paper on my desk?
You would reach the universe.
How would I reach the moon or not?
Yeah.
Twice.
You reach the sun.
Twice?
Twice. You can 4,000 times.
I would reach the moon 4,000 times,
Give or take.
give or take. Well, I would make it to the moon and back. I would make it to the moon and back
3,000 times now.
Twice.
80 billion times.
Oh my God.
80 billion times. Like 80 billion times. 80 billion!
Out of a 2-inch or a 3-inch thing of paper.
Here's my favorite. Prepare to have your mind blown. If you had a mole of pennies, let's say we threw a mole of pennies at Bree the moment she was born. Okay? Gave you a mole of pennies. Congratulations. Now let's say Bree spent $1 million every second of her life.
Bro, what would you need? How?
I don't know, but let's say Bree spent $1 million every second. So like Bree's 3 seconds old, she spent $3 million already. And let's say
Run out of money.
she lived for 100 years. So Bree croaks on her 100th birthday after spending $1 million every second of her life. You know how much money she'd have left over? She would have over 99.99% of her money left over. If I gave her a mole of pennies, she'd have 99.99% of her money left.
Okay, but
Bro, I wish you could buy a coffin.
It better be the bougiest coffin I've ever seen in my life. What? What is it?
There's like coin shortage right now, so using that many pennies would be kind of.
Oh my God!
yeah, I mean that's
Yeah, I know.
What am I saying? This is where your pencils back out on your notes. What am I saying? I'm saying a mole is a huge number. It is gargantuan, monstrous, humongous. Why is it a big number? Because we're using it to count very tiny things. Okay? You use a larger counting number when you're counting smaller things. Why do we use a pair for shoes? Because shoes are pretty big. Why do we use a dozen to count donuts? Well, they're a little bit smaller than a shoe. Why do we use a ream to count paper? Well, paper's a lot smaller than a donut. It's a lot thinner, okay? Why do we use a mole to count atoms and molecules? Because they're so tiny. Does that make sense? Okay? So that's the idea. I do got to pick up the pace here a little bit. So, what if I want a mole of water molecules? So you remember this equation, moles equals mass over formula weight. What is the formula weight of water? 18, if you remember that from last week. You never have to memorize that, as long as you can figure it out. So how many grams of water do I need to have 1 mole of water? I need 18. Following me? How many grams is 18? This would be 18 grams of water right here. Like, Mr. Pilcher, like what, like the whole Lake Erie thing? Back to the minute? Like, what?
So if that's a mole.
This is a mole of water because molecules are so small that there are 6.02 times 10 to the 23rd water molecules in just this area.
I don't buy it.
That's how small a molecule is.
She's obviously lying.
This man is lying. That's how small a molecule is. So even though a mole is such a big number, because we're counting such small things, and now it makes sense. Like, I don't want to count these by the dozen. If you count this by the dozen for the rest of your life, you would die way before you're done counting. Okay? But if you can count it in terms of moles, then it's something that you can use in lab in real life. Okay? So here's one thing that we learned, is that the formula weight, I once upon a time lied to you and said formula weight has no units. That's not true. Formula weight comes in grams per mole. Formula weight comes in grams per mole. Always do.
I have to obviously.
It's like, wait, is that true or not? Formula weight is in grams per mole. How many grams do I need to make a mole of something? That's the formula weight. So if you want 18, or you want a mole of water, you need 18 grams of water, because that really is saying, hey, the formula weight for water is 18 grams in every 1 mole. That's what that means. That's what that means. So we're here. I'm just going to fly through this. Not all moles are created the same. Do not write any of this down. You don't need to write any of this down. Aluminum, simple as Al, formula weight is 27. Here is 27 grams of aluminum. Okay? I bought up aluminum foil and just used an ice pick and smashed it into these little containers.
That seems interesting.
It was kind of difficult, shockingly difficult. But notice the new label, grams per mole on this.
Because
I
that
couldn't fit
would've
it in
been
there.
less fun.
I wanted to have the same container for all these. Now, sulfur, 32 grams per mole. Okay, here's 32 grams of sulfur. Smells really bad, by the way. Sodium sulfate, you need 142 grams of that to get 1 mole. Huh? Yes, it does. It stinks. And then copper sulfate. So that's that blue powder we used in lab last week to dehydrate. How come it was a powder last week, but I have the big chunks here?
Because you crushed it up last week.
I did crush it up. Why would I do that?
So that
Easier to
it
dehydrate.
The reaction goes faster, right? Kinetics, higher surface area. So I took this, ground to a powder. That's why I use that, because you can dehydrate the powder a lot faster than the big chunks. And I wanted to dehydrate in one class, right? Good stuff. So if I had 27 grams of aluminum, that might be a mole. But if I only had 27 grams of copper sulfate pentahydrate, that would only be like 0.1-ish moles of this. Okay? So just because you have the same mass of two things does not mean you have the same amount of molecules at all. We're clear on that? The formula weight is what tells you how many moles you got. So not all compounds are the same. Not all compounds are the same.
So mass and moles have no relation at all.
They have a relationship, but their relationship is different for any given compound and element. Does that make sense?
complicated relationship.
So like mass and moles relationship for aluminum is 27 grams per 1 mole.
I mean outside of the equation, there's no relation.
Now I don't know.
Now I'm a little...
Because it. Okay, so you.
They're independent, is
Yeah,
that what you
that's what
mean?
I'm saying.
Yeah, they're
of
independent.
each
They're
other.
independent,
not,
yeah. They are independent, but you can show a relationship between them
Yeah.
for any given element. Now, good question. Okay, let's talk about cheese sandwiches. You can still keep your pencil down for a second. The next slide you'll need it. But in this one, this is not supposed to be a trick question. Let's say I have a cheese sandwich. That'd be 2 slices of bread, 1 slice of cheese. You with me? Let's leave it at 1 slice of cheese and 2 slices of bread for now.
This is a serious question.
Oh, this is the last time. What do you want?
Is it like just cheese or is it like a grilled cheese?
Definitely, we're going grilled cheese.
Cane sauce. We'll go for grilled cheese. Anyways,
That's all.
all right. Here we go. Here we go. Faith, if I have 1 cheese sandwich, this is not a trick question. If I have 1 cheese sandwich, how many slices of bread would that require? 2 slices of bread. How many slices of cheese would that require?
2.
1. 1 slice of cheese, 2 slices of bread, right? Okay. Gozer, if I had 10 cheese sandwiches, how many slices of bread do I need? What's that? 20. How many slices of cheese do I need? 10. You with me? Right? What he really did was, he did, well, 2 slices of bread times 10, that's 20. 1 slice of cheese times 10, that's 10. Okay. If the math was so fast, he didn't really pay attention to how he did. He just knew that you need 20. With me so far? So this formula was 1 piece of cheese, 2 pieces of bread, right? That was like the formula for cheese. Now, what if we just convert that into chemistry, like we had a formula like calcium bromide, for example? Okay? It would not taste good or be edible. But now let's say I had 100 calcium bromides. Okay? Oswald, how many calcium atoms would be in 100 calcium bromides? 100. What about bromine atoms? That's right. Okay. I love that. That's Bracken. He's all jazzed up.
Your dad's got good music taste.
Now, Melania, what if I just call this moles instead? If I had 1 mole of calcium bromide, how many moles of calcium do I have? Yeah, you got 1 mole of calcium. How many moles of bromine do I have? That's right. Now, Melania could have said, well, you have 6.02 times 10 to the 23rd calciums, and then you'd have 12.04 times 10 to the 23rd bromines, or you could have said 1.204 times 10 to the 24th bromine. Like, she could have said those numbers; they would have all been correct, but it's a lot easier, it's a lot cleaner. Just like you have 1 mole of calcium, 2 moles of bromine. Does that kind of make sense? Because that counting number, the mole, makes this a lot cleaner. One more question for you: if I had 5 moles of calcium bromide, Nick, how many moles of calcium would that be? How many moles of bromine would that be? That's right. So really what he's doing there, he's like, okay, there's an invisible 1 here. 1 times 5 would give me 5 moles of calcium. 2 times 5 would give me 10 moles of bromine. Does that kind of make sense? Okay. Now, if we go to my next slide here. We'll skip this. We already got it. Yeah.
So like, what's the catch?
What do you mean what's the catch?
Why are we doing that? If it's just like multiplying.
Because it's going to be 1 step getting us to a further peak, if that makes sense. So this should be pretty easy. I'm hoping this is easy. Does that make sense? But we're not all the way there yet. There's more after this. Okay. Find this page of your packet. Mole conversions. It says mole conversions at the top. It's probably like the 6th or 7th page in there. So it says mole conversions at the top, but then we are looking at the section that says moles within a compound. So we're looking at the bottom half of that page where it says moles within a compound. Does that make sense? So here's that first one. We got 360 moles of H2O. 360 moles of H2O. So, Meg, how many moles of O are in 360 moles of H2O? Right. And how many moles of H are in 360 moles of H2O? Right. Yep, which would be 720. Exactly. Okay? Oh, spend like 30 seconds, see if you can do 1 or 2 more of those. I don't want to spend that So, the key idea is you're simply just going to multiply the subscript by how many moles you have. Okay, so with nitrogen and hydrogen here, you're going to have 34 moles of nitrogen, but you're going to have 3 times 34 moles of hydrogen, which in this case is going to be 102. Does that kind of make sense? This answer key is in the Monday folder, so you can always check it later. I don't want to run out of time here, though, before we get to the next step. Okay, so let's say we're here. This is on the back page. You don't need to take notes on this. It's just on the back page. Or you should follow along on the back page, but you don't need your notebook paper. I should be clear. Now, the real question is, how many grams of each, I want to say, element are present in a compound? So let's say we had 14.4 grams of iron oxide. Again, this is on the back of the worksheet you were just working on. Okay? So, if I want to find out how many moles of iron oxide I have, I need to find the what?
Formula weight.
Formula weight of iron oxide. Get that formula weight right now. Fe2O3. Find that formula weight. Fe2O3. Add up a couple of irons, 3 oxygens. Tell me what you get. Fe2O3. This is why you need that periodic table out. The trifecta notes packet table. What you got?
155.
I got a teeny bit more than that.
160.
160. That's what I got. Each iron is worth 56. plus the 48 you get from the 3 iron. So 56 plus 56 plus 16 plus 16 plus 16 should add to $1.60. So then I'm going to take that mass, 14.4, and divide by 160. What happened there? So how many moles of iron oxide am I dealing with? 14.4 divided by 160.
Ridiculous, like you got it.
0.09. Love it. And I think that most of us feel pretty good about this. This was last week's stuff. Okay? If I give you the mass of something, you should be able to tell me after you get the formula weight how many moles of that thing you have. Now, using the skill we just learned on the previous section, I want you to tell me how many moles of iron and how many moles of oxygen you have. So how many moles of iron would this be? If you have 0.09 of Fe2O3, how many moles of just Fe do you have? What's that? Not quite.
Like, don't you suck?
I have 0.09 moles of this whole thing. But each one of these has 2 irons in it. You see that? What's that? 0.18. 2 times 0.09 tells you how many individual irons you have. Does that make sense?
Sure.
So then how many oxygens would I have? 0.27. You see where I got that from? The 3, because there's 3 oxygens times 0.09 tells you have 0.27 moles of just oxygen by itself. Hey, what's the formula weight of iron all by itself? 56. You just used it, right, when you were adding up for iron oxide. So now I'm going to ask you to. I'm going to ask you to tell me how many grams of iron are in this whole sample. And I'm going to ask you how many grams of oxygen are in this whole sample. Okay, so you see how you can split it up? So calculate those two for me. Tell me how many grams of iron are in 14.4 grams of iron oxide. Tell me how many grams of oxygen are in 14.4 grams of iron oxide. Give me about 60 seconds. Calculate those two for me. Give me those two. Give me those two.
That's the subject.
Yeah. What's that?
So like the math makes sense, but why does the like the iron and oxygen, why does it go in evenly?
Why does it go into
The formula weight of iron and oxygen are not the same. You don't want to use 0.09 for both.
Oh, because you have moles of that whole thing, so iron oxides. So like, okay, with cheese sandwiches, then bread and cheese don't go in evenly. You got 2 pieces of bread for 1 piece of cheese, right? So like if I count in terms of sandwiches, that's one thing. Or if I want to count individual pieces of bread, that's going to be another. But like 0.18 moles of iron is still the same as 0.09 moles of iron oxide. And 0.27 moles is still the same as 0.09 moles of iron oxide. They're just breaking it out into different pieces. Does that kind of make sense? Maybe a little bit. Okay.
I understand how to do it, so I can just like do it.
Okay. Well, let's.
Forget about it makes sense.
Tomorrow we're going to do a lab where we're applying this, so maybe when you see it, you can get a little bit more understanding. Does that make sense? I do want to get there, but we might not have quite enough time to quite get you there today. Does that make sense?
Right.
But that's a good question, because then you're asking, wait, why are we even doing this? And that's important, because I don't want you guys to know how to just do this. I want you to know, like, why is this even a thing? So I really like that question.
Why?
Right. So you should have gotten 10.08 grams of iron and 4.32 grams of oxygen. So what you just figured out was, okay, if I had 14.4 grams of iron oxide, that means I would need 10.08 grams of iron and 4.32 grams of oxygen. Hey, these two should always add up to what?
14.4.
They should always add up to the original mass. In this case, it's 14.4. Does that make sense? That's the way to check yourself, because you got 10 here and you got like 27 over here. You're like, wait a second, something's wrong. Okay? So, you now have the skills to finish the rest of this worksheet and the skills necessary to do the lecture questions. Now, there's only about 2 minutes till class is over, so you don't have to start the lecture questions right now if you don't want to. The answer key to this is in the Monday folder.